Hi there, math friends. I hope you're having a wonderful day today. Today we're going to be talking about rational numbers. Just to give you a kind of an overview, we have 2 pages worth of notes today. I'll try to get kind of quickly through that first page. The first page is basically background and overview. The second page is what's going to really help you know how to do the homework problems for today. So starting with this first page, and just write down whatever is useful to you. I know some of you print out the notes, some of you don't. That's okay. If you don't have a printout of the notes, just write down what is useful for you. So let's start with our I can statement for today. I can understand rational numbers. So rational goes there. I can understand rational numbers in fraction and decimal form. All right, so first of all in the warm-up, just a little bit of review. What are the integers? Integers are the positive and negative whole numbers, including 0. Okay, and if you remembered that, that is awesome. Good for you. Now, what is the root of the word rational? It's right here. Do you guys know this word ratio? Ratio. So for a ratio, you could have like 1 to 3, and you could write it like that, 1 to 3, or you could write it like this, 1 to 3, or most commonly in math, you could write it just like a fraction, 1 to 3. Okay? Let's keep going. We like working with integers because they are nice whole numbers that are very familiar. So integers are not really like fractions. They're not the in-between numbers, they're the whole numbers. But now with rational numbers, we're going to be talking more about fractions and decimals. For example 1, graph and label the following integers on the number line. Okay, so if you put 0 here, then you'd have -4 right there, and you'd have 5 over here, and you'd have 2 right here. Kind of like that. These are pretty easy, but most things in the real world don't happen in whole number increments. Boy, isn't that true? Can you think of some examples? Okay, cooking, like you have 1 3/4 cups of flour for your cookie recipe. Or with money, how often does something cost $2 or $10? Usually it'll be like $4.59 or something like that. So those are just some of many, many examples in the real world of those in-between numbers coming in handy. We need to make sure we're comfortable and familiar with other types of numbers. One of the main types of numbers we'll need to work with are called, guess what? Rational numbers. There's that word again, rational. Numbers, okay, so rational numbers are numbers that can be written as a ratio of 2 numbers. What does that mean? Well, we'll see in the next line, don't worry. i.e., rational numbers can be written as a fraction. That's the important part right there. So all this line right here is saying is that the numbers can be written as a fraction. So rational numbers can be written as a fraction. When someone says rational number, you should think, guess what? Fraction. Let's do a few examples here. So rational numbers, okay, let's do a fraction. How about 1/5? There's a rational number. What if you did, whoop, drops my pen. Okay, what if you did 2 2/5? You've got like a whole number and a fraction? That's totally fine. That is still a rational number. What if you did 0.12? Well, that's a decimal, and it can be written as a fraction, which is something we're about to learn. And so that is a rational number also. Even if you had a repeating decimal like this, 0.333 forever, that can be written as a decimal, so that is rational also. And if you don't know how to convert that to a decimal, that is okay. I mean, to a fraction. We're going to learn that soon. So all of these are examples of rational numbers. An example of a number that is not rational would be, well, the most classic example is the number pi, because it doesn't repeat and it doesn't ever end. It just keeps going. So it's like 3.1415, then it goes on and on and on and on and on forever. And people have contests to see how many hundreds of digits of pi they can memorize. But it goes on forever. I mean, there's millions of digits of pi. It's crazy. And I should go on so I don't take all of your time. Let's go to example number 2. Graph and label the following rational numbers. Okay, and you can see they're not whole numbers, they're little decimals, right? So this is kind of weird looking, I know. We've got 0 here on the number line, and we've got 1 here on the number line. And what this is it just kind of blows up that in-between space. So instead of having this teeny little space to write in, we've made it bigger so you can really see what's going on. So we have 0 down here and 1 right here. So now I'm just going to label these incremental spaces in between. And I'm going to use decimals. So we've got 0.1, which is said 1/10, right? And now we have 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, and 9/10. You don't really have to worry about labeling all these on there. 9/10 is going to be here, right? 5/10 is going to be here. That's just that kind of thing. Now let's look at this same idea a different way. What if on the expanded version, here, let's come down here this time. This is still 0, and this is still 1. So this is still like the little pop-out expanded thing, but this time we're going to use fractions instead of decimals. And don't worry about these so much. So for the fractions, instead of writing 0.1 or 1/10 that way, I'm going to write 1/10 this way. You notice it said the same, but it looks completely different, right? So 1/10 there, 1/10 here. Here I'm going to write 2/10, 3/10. You get the idea. We're just going to keep writing it all the way down, all the way up to 9/10. And then this would be 10/10, or you could just say it as 1, either way. So just kind of giving you an idea that these decimals are the same as these fractions. Again, don't worry about locating all these on there. That's not really the point of this exercise. Let's go on to some of these blanks. Most people like decimals more than fractions. Is that true for you? Do you like decimals more than fractions? I don't know. I haven't gotten that feeling from my students before. I'm curious. It seems like they are easier to work with, and they are definitely easier to put into a calculator. Well, that's true. Okay. However, fractions have some very nice properties that decimals do not. When we need to write an exact answer, fractions are definitely the way to go. That is true. The bottom line is we need to be good with working with both types of rational numbers, fractions and decimals. Hopefully by the time we're done with this unit, you will like fractions as much, if not more, than decimals. You guys can let me know about that. Maybe you already like fractions better. I don't know. Now, on to the next page. This is where we really start talking about how to do this morning's, whatever, assignment. Changing a fraction to a decimal. And then down here, we're going to do changing a decimal to a fraction. So we're going to go both ways. All right, back up to the top. Look at the fraction 3/8. What operation is used to make the fraction? So as we've talked about, a fraction is kind of the same thing as a division problem. So it says hint, it may have something to do with why people tend not to like fractions. Again, it's like trying to tell you you don't like fractions. I don't know what's up with this. And it's also saying that because a fraction problem is essentially division. Do you guys not like division? Division's fine, right? I don't know. This paper's just crazy. We're just going to go with it though. A fraction is essentially a division problem. And that's all you need to learn from this part right here. So let's change the fraction 3/8 to a decimal without a calculator using the following procedure. And that procedure is just going to be division. So you have to know what's divided by what. If I say it, I'm going to start with the top number and go to the bottom. So change the fraction 3 divided by 8. 3 divided by 8. So I'm going to take my 3 and I'm going to divide it by 8. So 3 goes under the little thing there, and then 8 goes on the outside. Now, if you remember how to do this, 8 doesn't go into 3, so you have to do the 0.0 thing here. And now 8 times 3 is 24. So it goes like that, and then you subtract and you get 6, so we're going to add another 0. Now 8 doesn't go evenly into 60, so we're going to do 8 times 7 is 56. Subtract, you get a 4. 8 won't go into 4 either. So let's bring down another 0. And, oh, that one goes evenly. 8 times 5 is 40. And then we have 0 there. So 3/8 is the same thing as 0.375. Okay, now let's practice with another one. We're changing the fraction 7/9 to a decimal. So again, that's 7 divided by 9. So 7 goes inside the little thing and 9 goes on the outside. Now 9 won't fit inside 7, so we have to do the little 0. We do 0.0, right? And then the point goes on top. Let's see, 9 times 7 is going to give us 63. And then we're going to subtract and get a 7. And then we'll bring down a 0. Oh, look, we have 70 again. Okay, so 9 times 7 is 63. And then look, we have another 7 and another 0. And we could do this all day. But you guys probably know the answer that we're supposed to be looking for here. When you have a repeating decimal that goes on forever, you're just going to put a line over it. And that means the same thing as 0.77777 repeating forever and ever and ever. This is one of the reasons that we say that fractions are a little bit more useful, because you can write it and have it be a complete answer without the whole repeating business. But 0.7 repeating forever is also an accurate way to do that. And when they say change this to a decimal, this is exactly how you do it. All right, so what would we do differently if we were asked to change the fraction 4 7/9 to a decimal? So see up here, we changed 7/9 to a decimal, and here they're talking about 4 7/9. Two different ways you could do this. You could make it into what they call an improper fraction. 9 times 4 is 36. 36 plus 7 is 43. So you could change that to 43 over 9, because that means the same thing. And then you could just do your same division problem. 43 divided by 9. And you would get, I'm not going to go through it all, but you would get 4.77777. Or you could think of this fraction as 4 plus 7 over 9, which is accurate. That's how it works. We already know that 7 over 9 is 0.77777. So we know that that would be 4.7 repeating. So either way, that would be 4.7 repeating. Okay, please note, when we change a fraction to a decimal, the numbers after the decimal will terminate. What does that mean? Terminate means end. Or they will form a repeating pattern. Either way, it's a rational number. The only way it's irrational is if it never repeats and never ends. Okay, so that's going from a fraction to a decimal. Now let's go from decimal to a fraction, which I think you'll find is maybe a little bit easier. To change a decimal to a fraction, we simply need to say the number the right way. What are we talking about here? For example, how would you say the number 0.45? Well, frankly, I usually say 0.45, but the proper way to say it is 45 hundredths. So if you say the number 45 hundredths, how do you spell that? With a D there or no D? I don't know. You can correct me later. But if you think about what you're saying there, 45 hundredths, we actually have a fraction, like 45 hundredths, right? So if they ask you to change the decimal 0.45 to a fraction in reduced form, you would start out with your 45 hundredths, and then all you have to do is reduce it. In other words, simplify it. So what's my greatest common factor? I don't know, maybe a 5. 45 divided by 5 gives me 9. And 100 divided by 5 gives me 20. Yeah, that looks good. So I can't reduce that or simplify that anymore, so that would be my answer. Okay, now let's go with each of these and change each decimal to a fraction in reduced form. In other words, fully simplified. So here we have 18 hundredths. So we're just going to go 18 over 100. Okay, what's a good factor for those? I know they're both even numbers, so they're both divisible by 2. Let's go ahead and do that. So that equals 18 divided by 2 is 9. 100 divided by 2 is 50. Can that be simplified further? No, there's no common factors there, so we're done with that. Okay, here we have 69 hundredths, so that would be 69 over 100. Do we have any common factors here? 2 goes into 100, but not into 69. 3 would go into 69, but not into 100. I think it is fully simplified, so we're done with that one. Now over here we have 9/10ths. So we put the 9 on top, and this time we're going to put a 10 on bottom because it's just tenths. Can this be simplified anymore? No, that's fully simplified also. So that one is complete. Let's go ahead and take a quick peek at your assignment. So here it is, rational numbers in fraction and decimal form. So here you're going to start with fractions and you're going to go to a decimal. don't use a calculator and show all of your work. So if you just keep in mind, it's always 5 divided by 8. So top number divided by bottom number. That means the top number is going to go inside the little symbol, and the bottom number is going to go outside of it. And if you divide it that way, you should be good. With a number like this, you have that improper fraction. You could convert it, no, I'm sorry, a mixed number. You could convert it to an improper fraction, or you could just kind of set your 4 aside. I'm going to set my 4 aside because it's easier. So I'm not going to think about the 4. And now I'm going to convert 1/125th. So 1 goes under the little thing, and then 125 goes on the outside. And then this 4 is just sort of over here in a box by itself. So here I would start adding zeros, and I would, let's see, 125 goes into 1,000. How many times? Do the math on that. And here, you know what, let's just do it together. 125 goes into 1,000 how many times? 125 times 2 is 250. I'm going to say 8 times. Let's see if I'm right. Actually, it shouldn't go there. Sorry, it should go there. 0.008. I don't do a whole lot of long division in 7th grade math, so it's good for me to get this practice too. 8 times 5 is 40. 8 times 2 is 16, plus 4 is 20. 8 times 1 is 8, plus 2 is 10. Okay, looks like we got it right. So the 1/125 is going to be equal to 0.008. But now we need to remember the 4 also, so just add them together, and you would get 4.008. So you can really take that whole number out front and just put it in front of the decimal point, and you'll be just fine. And if any of this doesn't make sense, make sure you join me for the next study session, okay? I'd love to go over this with you guys. And then down here you have where you go from a decimal to a fraction. So just remember, like this would be 4/10. So you would go 4/10 and then simplify, don't forget. This is 18/100, so it would be 18/100 and then simplify. And I don't see anything else that's sticking out to me as really tricky. Again, if you have questions, let me know. Meet me at a study session. And have a great day. I'll see you guys later. Bye.